Okay. So this is a common emitter amplifier, and it is known as without bypass capacitor. And uh, the voltage biasing network we have here is voltage divider biasing. What we have to determine in that exercise, we have to determine a few things. Number one, we have to determine um, the expression for VI, the expression for V naught, then RIB. So the impedance that you're going to see looking into this side, and then RI, and then gain. Okay. So these are the gain, which is in fact V naught over VI. So these are the expression that we have to derive after analyzing this amplifier only for small signal. Okay, let's begin. So last class, we already learned that in order to analyze an amplifier only for small signal, first thing we need to do is to determine the small signal parameter. The small signal. So determine. So number one, determine the small parameters. Then what are the small signal parameters? The small signal parameters are GM, then R5, and then RE. So what is the expression for GM? So GM is equal to DCIC divided by VT. That's what we learned last class. And what is R5? Beta over GM. And what is RE? Alpha over GM. So that means in all cases, in order to determine the small signal parameters, I need to determine what? I need to determine IC. Determine IC. So next question is, how are we going to determine IC? For that, I need to analyze the BGT only for large signal. Okay. Oh, let's see. So let's see. To determine IC, analyze the amplifier only for DC signal. So draw the DC circuit. So I need to draw this in. Okay, what are the steps to draw this DC equivalent circuit? Let's see, how can we draw the DC equivalent circuit? So this is our amplifier. So this is our amplifier. So this is our amplifier. Now, we learned last class that for a DC signal, the capacitor are open. For DC signal, the number one capacitor, so steps to draw the steps to draw the DC equivalent circuit. What are the steps? Number one, capacitors are opened. We need, because to a DC signal, we know that capacitors are treated as open circuit. Then applying superposition theorem, short AC or small signal sources. So let's do both of them. Okay, first of all, open the capacitor. So you have these two capacitors. The capacitor is open. C2, it's open. And then we said that one, the AC signal source to be shorted. So we'll say the capacitor is open. How about if you open the capacitor? What does that mean? Doesn't matter you short it out or not. So that means it is enough to do this, and it doesn't require. It's not necessary to apply superposition theorem, because as soon as you open the capacitor, as long as you open the capacitors, doesn't matter whether you keep the signal source or short it. Now what happens? You see, this part and this part of the circuits are already disconnected from the middle part. So that means for VCC, what are the things that we have got? R1, R2, RC, and RE, and we have got a voltage divider network. And we already learned that we know how to solve it. So let's say we have solved it. And after solution, we get the expression for IC equals to, for that particular circuit, beta times VTH minus VBE RTH plus 1 plus beta RA. We derived it. Let's assume that right now we have derived it. And where VTH equals to R2 divided by R1 plus R2 times VCC, and RTH equals to R1 parallel R2. Okay. So now that I have derived obtained IC, so now I know what are the values. So now I know I can determine GM. So I can determine GM. So I can determine GM. I can determine R pi, and then I can determine RE. It's the first part done. So now my small signal parameters, the small signal parameters for the amplifiers are determined. Okay. So next, what do I have to do? Now I'm ready to analyze the amplifier. Analyze the amplifier only for large small signal. Okay, let's bring the amplifier back on. Now next, for that I have to draw, the next step should be draw the AC equivalent circuit, AC or circuit. Okay. So how can we draw the AC equivalent circuit? Steps. Number one, apply superposition theorem, turn off all the DC sources. Turn off all this. In that DC voltage source shorted and DC current source, if there is any, opened. So our step should be turn off all the DC sources. Now, fortunately or unfortunately, it doesn't matter. We don't have any DC current, so we have a DC voltage source. So this is our DC voltage, VCC. Okay. So VCC can be, I can draw the VCC like this, DC voltage source like this. So that is our DC voltage source. So to short it. So if you want to short it, what should I do? This is shorted. Okay, DC also. We don't have anything else. We don't have any DC voltage source. You'll find. Steps 2. We already learned that small signal equivalent circuit means the amplifier is only for small signal. And we know that for high frequency, the capacitors, okay, capacitors shorted are capacitors shorted. Okay. So how many capacitor you have got? So you have got this capacitor and we have got this capacitor. So these two capacitors are shorted. This capacitor shorted and this capacitor is shorted. Okay. So if this is the case, notice now what are the things that we have in the circuit? In the circuit, only source available is Vs, which is a small signal source. And there is no DC voltage source. So Vs is set to 0. Vs is set to 0. No DC signal source. Now, during the exam, to be able to draw the AC equivalent circuit is very important and it carries good portion of the mark, some marks. If you make some mistake, for example, you have shorted the capacitors, but you forget to, remove the DC voltage source. Okay. You remove the DC voltage source. So it means that you haven't been your concept is not clear. Okay. So now that I know that what is the base current, it will be the base current IB. Sorry. Base current IB. Okay. This is our VBE. Okay. So we know that what is IB. Amra jani je IB is equal to VBE divided by R pi. Okay. And IC is equal to GM VBE. Okay. Okay. So next thing would be, now we are ready to analyze. So for analyzing, what are we going to do? We're going to replace the BGT, one of the model. So let's replace the BGT with, let's say, we replace it pi model. So let me draw the pi model first. Pi model. First of all, we draw the model. There's our base, collector, emitter. Okay. Oh, sorry. Before doing that, I have to do one more step. So I'll just do it later. Okay. Okay. So what is the thing that I have to do for me to do? Now, it is possible for me to simplify the circuit, draw it in simplified form. Uh, let's say we know that is our base. So that is our collector. This is our emitter, and this is our ground. So ground, so ground and ground. Okay. Now, uh, so let's say we draw the BGT. Okay. So notice from the base terminal, we have got one resistance R2 connected to the ground. So let's draw it. R2 goes to the ground. And then we have got another resistance R1, which goes to what? It also goes to the ground. You see, from base, it goes to the ground. Okay. So what does that mean? R1 and R2 are in fact connected parallel to each other. So that means I can so R1 and R2 are essentially connected to parallel to each other. So then from there it goes to the RS, and from RS it goes to VS. VS. Okay, so this is what base side. And the emitter side, it is connected to RE. And the collector side, from the collector, one resistance go to RC. You see, from collector, it goes to another, from collector. What else other terminal goes? It goes to RL. Now, from C to ground, RC, and C to ground, RL. So that means RC and RL are connected parallel to. So that is the simplified diagram of the amplifier. In that, so that is our base, and this point is our V. This is VI, and this is our V naught. And we are to determine what? RIB and RI, the input impedance, right? Okay. So from there, I'm going to draw replace the BGT with this model. So if it's model, then rest of the BGT I'm going to simply connect as it is. So what I can do, I can, let's say, copy and then paste. Simply as there. Okay. And again, rest of the circuit. There. And then the emitter terminal. Okay. So here it is R pi, and this is GM VBE, right? And that is our VBE plus minus. So now this is the circuit that we're going to, on which we are going to work. So you see, we started from here. That is our amplifier. And we're instructed to analyze this amplifier only for small signal. So the steps that we followed. First of all, we determined the small signal parameters, which is GM, R pi, and RE. Right? Okay. And what is GM is DCIC divided by VT. So that means I have to determine DCIC. What should we do? I need to draw the DC equivalent circuit and analyze it. So what did I do? In order to draw the DC equivalent circuit, I opened the capacitor. And we could also, remove the AC signal source. So what we are left with? We found that so it's a voltage divider network. Let's say we analyzed it, we obtained the expression for IC, and from there we have obtained the expression for GM, R pi, and RE. Now once they are obtained, so what we did? We draw the AC equivalent circuit. For that, we turn off all the DC voltage source, and then capacitors are shorted. So in this form, and then we simplify it, and from that we replace the BGT with F models. Now this is the form that we are used to. Okay. Now we're going to determine VI, V naught, and etc. Okay. In order to determine VI, so what I'm going to do, so let's say this is our base. So what is the base current? The base current is small signal base current. Here it is our small signal collector current, and it is our small signal emitter current. Okay. In order to do VI, so if we apply a KVL from ground, from here to here, so from ground up to that point, like this, I KVL from ground, so it is plus, minus, plus, minus. So we get what? We get plus IE RE, this voltage drop plus this voltage drop, plus IB R pi is equal to VI. So that can be written as IE and IB. How are they related? IE is equal to 1 plus beta RE. VI equals to IB R pi plus 1 plus beta RE I times IB. So that gives us If I take IB out, then I get R pi plus 1 plus beta R. Okay. So that is the expression for, so now I found the expression for VI. Now I am going to use this expression to determine RIB. So RIB. So notice, what is RIB? RIB is the, in fact, it should be something like that. RIB is the impedance looking into the base set. Okay, what does that mean? So let's say let's go back to our DC circuit. Let's say we have got a circuit like this. Let me draw it. Okay, let's say R1, R2, R3, and this is our the source. So you are asked to determine the R equivalent. আমরা কি শিখেছিলাম? R equivalent is what? R equivalent is, first of all, R2 and R3 are parallel. And তার সাথে R1 is in series. So I can write as R1 plus R2 parallel R3. So that is, the circuit looks like this. Circuit looks like this. And let's say you are asked to determine the current I. Let's say, I. অথবা let's say II. And the voltage here is VI. So that's the current you are asked to determine. তাহলে আমরা কি হবে? Circuit looks like this. VI II. That's our R equivalent. So what is II? II is simply VI divided by R equivalent. তাই না? VI divided by R equivalent. Okay. So now on the other hand, I can do what? I can use this expression R equivalent as what? VI divided by II. So that means that somehow, if I can measure the current, calculate the current. If I can measure the current here, let's say let's use an emitter to measure the current, and a voltmeter to measure this voltage or this voltage. Let's say this voltage. So somehow we measure this voltage. Use a voltmeter to measure this voltage. So then if you divide this voltage with this current, measured voltage divided by measured current, that gives us what? That gives us R equivalent. এখন আসলে R equivalent মানে কি? R equivalent মানে হচ্ছে এই everything. R equivalent মানে হচ্ছে this and this is same. So everything inside is our R equivalent. Okay. So same thing that would be to apply. So the idea is that if you want to determine, there is one way. So there is one way to determine the equivalent resistance by doing this. R2 parallel R3, and then R1 is in series. That's one way. Another way is that I determine the circuit, I determine the voltage between these 2 points and measure the current and divide the voltage with the current. So that's what we're going to do to determine this. Just a second. So if I want to determine RIB, so that means RIB, so the resistance looking into to the right. So what should I do? All I need to is to determine the expression for VI and what is the current. Same as here. All I determine is the voltage between these two terminal and the current. So that's what I'm going to do. So RIB should be must be voltage between the terminal divided by the current. What is the current? IB. Okay. So if this is the case, I know the expression for VI, which is IB so divided by IB. IB cancel out. RIB is R pi plus 1 plus beta. So I found out the expression. তার মানে হচ্ছে whatever the things we have got, let's everything to my life. It can be replaced with what? R equivalent. Or here is RIB. RIB. So the same voltage VI, RIB. So everything inside is can be replaced with our equivalent resistance. That's it. Now, next I'm going to determine RI. So if I take two step backs, what you're going to see, if you see from here, you're only going to see R1, R2, and R by R, RIB are parallel. So that means RI is very simple. R1 parallel, R2 parallel, RIB. তাহলে I can, simplify it is like this. So it can be RI. So entire circuit to the source, it has reduced it to this form, a signal source RS and RI. So that is our VI. And second thing, I can find out what is the VI. VI using voltage dividers, VI can be written as RI divided by RS plus RI VS. Okay. So I have determined VI, RIB, RI. I need to determine V0. In order to determine V0, what should I do? Now, what is V0? V0 is the voltage at that terminal. Or you can say the voltage drop across RC and RL parallel. And what is the voltage? So it's RC and RL parallel. So let's say the current flowing here is I0. Okay. So I can write V naught as I naught times RC parallel RL. So V naught as I naught times RC parallel RL. Now what is I naught? What is I naught? I naught দেখেন I naught and IC same, but they are in opposite direction. So I can write I naught as minus IC. I naught as minus IC RC parallel RL. And what is minus IC? So minus GM VBE RC parallel RL. তাহলে V naught expression পেয়ে গেলাম. And then finally I need to determine the gain AV, which is V naught over VI, which is minus GM VBE RC parallel RL divided by what? VI is equal to IB R5 plus 1 plus beta RE. Okay. So this expression, now we have got VB over IB. So VB over IB is in fact R5. So I can replace the entire things. With R5. So that is our expression for So that's it. Any question so far?
স্যার একটু স্ক্রল আপ করবেন
Sure.
স্যার এখানে ভিআই এর আরো একটা ইকুয়েশন পাইলাম
এটা just trying our establishing the relationship of the VI with VS. আমাদের আলটিমেটলি দরকার কি VI, তাই না?
জি স্যার
So it's not, in that case, although it's not required, it's not being used. ঠিক আছে. আচ্ছা, just a second. Any other question? So that is the thing that you have to do. So in the exams you will have a circuit like that. In that you have to draw the DC equivalent circuit. You have to draw the AC equivalent circuit. You have to replace the BGT with model, and then you do all those things. You have to find the expression for VI, V naught, RI, V, RI, all those expressions that you have to determine and find. So that is it's a full question. So somehow if you can do it right, okay, then it carries a lot. আপনি যদি ঠিক আছে, okay, just a second. একটু সময় দেন আমাকে। Okay, so let's see. I don't have the, I don't have the material with me right now. Let's see how I can, if you can, uh,
The question ছিল
so now we're going to find the, I can find the notes. So let's see how much I can grab it from MOSFET, small signal analysis. MOS. Okay. No, I don't think I have. I need the notes. I need the notes. This material is not available from my home PC. Let's check. Let's just keep it here with me. All right, I got it. Okay. Just sorry. Okay. Yeah. So now we want to find out the same thing for a MOSFET. So let's say this is a typical uh, MOS amplifier. Here is the input signal Vi, and this is the biasing. This is for biasing. So and output is taken V0 from here. So V0. This is our V0, and this is our Vi, and this is biased by BJT. First of all, we're going to determine the small signal parameter. Okay. Again, same thing applies. If if the parameters current and voltage are capital and corresponding subscripts are also capital, it indicates DC values, all small AC values, and mixed, it is total instantaneous values. Okay. Okay. So of course, since the MOSFET, it is operating in the saturation region. And VGS, what is the VGS? VGS, instantaneous VGS, it is a two component. VGS equals to VGS plus small signal VGS. Okay. And then we know the current. We know the current ID in for large signal Kn VGS minus VTN whole square. VGS minus VTN whole square. Okay. Now, if this is the case, what is the instantaneous drain current? So, instantaneous drain current if this is our circuit. So instantaneous drain current would be ID would be what? Kn instantaneous gate to source voltage minus VTN whole square. So that can be written as Kn VGS plus small signal VGS whole square minus VTN. Sorry. Minus VTN whole square. Okay. So now I just, write it in this way. So Kn VGS minus VTN plus VGS whole square. So if I write it, Kn VGS minus VTN whole square plus 2 VGS minus VTN times VGS plus VGS square. Okay. So this part, since VGS is a small signal and square it even more smaller, we can ignore it. So that gives us Kn VGS minus VTN whole square plus 2 Kn VTN times VGS. Now that is already we know ID. So I can write is ID. Instantaneous or drain current. It has going to have two components. One is ID and the other component must be what? The small signal ID. So it is our small signal drain current, which is 2 Kn VGS minus VTN times VGS. So that we can call it our GM. So তার মানে হচ্ছে ID is equal to GM times VGS. Or I can say what is GM? GM is equal to ID over VGS which is in fact equal to 2 Kn VGS minus VT whole square, not whole square. Now there is another expression for so and VGS. If you rearrange these things, it can be written as 2 root Kn ID. So 2 root. So GM can be written as GM 2 root Kn ID. So either this equation or this equation you can use to determine GM. Now, good thing about MOSFET is that unlike BGT, where there are 3 parameters, there are three small signal parameters, and they are GM, R pi, and RE, and for BGT. And here, only one parameter, MOSFET. It's GM. Okay? So, I know I can write it is equal to GM. ID is equal to GM VGS. So, okay. So then I want to determine VDS. What's VDS? VDS should be what? VDS should be instantaneous VDS, VDD minus instantaneous ID times RD. Okay. And then we know that VDD minus instantaneous ID have 2 components, ID plus ID. Swap it. Minus ID, RD. You might find the similarity between, and that is in fact DC-VDD, DC-VDS. So this is our DC-VDS minus ID, RD. Is our instantaneous VDS. Okay. So that must be our small signal VDS. So it is going to have 2 components, VDS plus small signal VDS. So that gives us minus ID, RD, minus RD, RD. Okay. So minus ID, RD. So then what will be the equivalent circuit? Okay. MOSFET equivalent circuit. So if it is a MOSFET, it's small signal equivalent circuit. So it is here is VGS, okay, and this is VDS, right? IG is equal to 0, and this is our ID. This is also our ID. So that can be written because between gate and source, it is gate current is 0. It is like an open circuit. So it's like an open circuit. Gate, and let's say this is our source. So between gate and source, it is our open circuit. So IG is equal to 0. So all we have, we're going to have VGS. Between gate and source is a dependent current source. This ID is equal to what? GM VGS. So it will be dependent current source. Drain, right? ID, GM, VGS. So that is the model for MOSFET. Okay. This is model for MOSFET. So let's consider one circuit. Okay. The same way, so you see, same way where we can draw the DC equivalent circuit, Same procedure as a BGT, open the capacitor. Why we need to draw? Because I need to determine GM. And GM is what? GM is KN root, 2 root KN ID. ID. So I need to determine ID. For that, I need to draw the DC equivalent circuit. So if I open it, open the capacitor, so you get this circuit. Open the capacitor. Okay, and then R1, R2, RS. So if you solve it, I can determine ID. Of course, when you're going to solve it, we're going to consider the BGT is operating in saturation region. Align. So next, we're going to draw the AC equivalent circuit. AC equivalent circuit. Let me draw the AC equivalent circuit. So what are the steps? Capacitors are same steps. Capacitor, shorted. DC sources, turned off. Okay. So let's do this. So we have a DC voltage source. So let's draw it this way. And then we have a capacitor here. The capacitor will be shorted. And this is the BSS, RS, R1, R2, RS, and we take the output from here, V0. So this DC voltage source should be shorted. Okay. Now we can simplify it. Again, R1, R2 are parallel to each other. You can take that much. Okay. So R1 and R2 are parallel to each other. So I can connect another resistance R1 here. And the source is connected to the ground and the drain is connected to the ground. So drain goes to the ground straight away. The ground. So next, what should our next step? Replace the BG MOSFET with this model and draw the small signal equivalent. Okay, first thing first, replace it. Replace the MOSFET with open circuit. Sorry, between gate and source. So let's say this is our gate. This is our source. Gate and source, which is VGS open. Okay, and then the drain terminal. ID. This is our gate, source, and drain. Now, what are the things connected? Okay, drain is connected to the ground. The drain is connected to the ground. Okay. What is source connected to? The source is connected to RS, and through it, it's connected to the ground. And the gate terminal, so gate terminal is connected to R1, R2. Gate terminal is connected to R1, RS, VS. Okay, so that is our equivalent circuit with the model. Here, let's say we may have to determine same as before, RI, RIG, and then RI, and then VI. So VI, right? And V naught is here. V naught is here. V naught is here. Okay. First of all, how can you determine VI? Okay, determining VI again, the current is ID here. So if I apply KVL from this point to this point, we get what? Plus VI. VI equals to plus ID RS plus VGS. Right? What is IG? ID. So GM VGS times RS plus VGS. So if I take VGS out, we can get 1 plus GM RS. That's the VI. Okay. Then what is RIS? Since it's open circuit, RIS, let's say RIS. RIS is open. So RIS infinity, open circuit. And then what is RI? RI ki dekhche ekhan theke R1 shudhu R2 parallel. So R1 parallel R2 parallel infinity. That is our R1 parallel R2. And then V naught. What is V naught? V naught should be simply V naught ID RS. And then gain AV. So V naught over VI, which is GM VGS, GM VGS. Okay, so V naught GM VGS RS over VGS 1 plus GM RS. So VGS cancel out. So gain is GM RS divided by 1 plus GM RS. That is our approach. It is incidentally even much simpler than MOSFET, than BJT. Any questions? So next class, I'm going to solve 1 or 2 more problem on MOS amplifier. And on that, I need to tell you that, okay, few announcement. Number 1, so next Wednesday, inshallah, if everything goes all right, I'm going to take our third quiz, and it will be based on small signal analysis. Small signal analysis, number 1. Then I'm going to send you a link where you are going in which you're going to put your name down to form the group for design project. So design project for each group, you should not have more than 3 members, and all the members should be from the same section. Yeah, so I'm going to post that problem soon, and probably in the next class, Monday, we're going to go for a discussion as to how we are going to conduct the design. So make sure that you are present.